Welcome and good day, students. Today, let's talk about physics in mechanics, focusing on motion in one dimension. So we are going to start with identify all the subtopics in the chapter 2. Let's begin with the first subtopic 2.1, discussing about parameters involved in a linear motion, such as displacement, velocity, and acceleration. 2.2 is about motion diagrams. 2.3 is one-dimension motion with constant acceleration. And lastly, 2.4 is free-falling object. But the subtopic 2.4 will be discussed on the next video. In order to study all the subtopics given, there are 4 learning outcomes need to be achieved by the student at the end of the session. Number 1, students should be able to define all the parameters for the motion in one dimension, such as position, distance, displacement, average speed, average velocity, and average acceleration. Number 2, students should be able to calculate all the parameters involved in a linear motion. Number 3, students should be able to apply 4 kinematic equations of motion with constant acceleration when solving the problem. And last one, number 4, students should be able to sketch, analyze, and use the graph of displacement versus time, a graph of velocity versus time, and last one, a graph of acceleration versus time when solving the problem related to a body with a constant acceleration. Motion involves the displacement of an object from one position in space and time to another position. To explain about this motion, we require a coordinate system with a specific origin. Position can be defined in terms of one frame of reference. It is a choice of coordinate axis that will define a starting point for measuring the motion. In this chapter, we focus on one-dimensional motion only. So you may choose your motion either along x-axis or y-axis. For example, an athlete walks along x-axis as shown in the figure. A displacement is defined as the change in position between initial and final position. It is symbolized as delta x. To calculate the displacement, you may use the formula as displacement delta x equals to final position xf minus initial position xi. The SI unit for displacement is in meter. Displacement is an example of vector quantity, but distance is the total length of travel object. It has the same SI unit with the displacement, which is in meter. This is example of displacement. We have two situations given. The first situation is from point A to point B. For example, if the car moves to the right from position A at 30 meter and stop at position B, which has 52 meter, the displacement of the car, delta x, becomes positive 22 meter. We say that the displacement is positive, and this indicates the motion was in the positive x direction. Meanwhile, the second situation is from point C to F. For example, if the car moved to the left from position C at 38 meter and stop at position F at negative 53 meter, so the new displacement delta x of the car now is negative 91 meter. We say that this displacement is negative and indicate the motion of the car was in the negative x direction too. Any measurement of object can be classified into two groups of quantities. The first one is scalar quantities, which are completely described by magnitude only, for example, speed and distance. The second group is vector quantities, which need both magnitude or size and its direction. For example, displacement, acceleration, and velocity. Speed is a scalar quantity. For example, Ahmad drives his car at a speed of 90 km per hour. The SI unit for the speed is meter per second. What is average speed? Average speed of an object is defined as the total distance traveled divided by the total time elapsed. By the formula, you may write average speed v equals to path length d over total time taken t. Average speed totally ignores any variation in the object's actual motion during the trip. Both magnitude of path length and the total time taken are always positive. As the result, the speed or average speed also will become positive. The SI unit of the average speed is meter per second. So now, what is the difference between the path length and distance of a moving object? The distance is the length of a straight line joining between the 2 points. The distance depends only on the endpoints, but doesn't depend on what happened between these points. So we can say that distance is the magnitude of displacement. However, the path length or total distance traveled is the length of an actual path traveled across between the 2 points, including any retracing of the step. The path length will depend on the actual route taken during the trip. Velocity is a vector quantity having both magnitude and direction. When a moving object undergoes a displacement and takes time to move, we say that the object has a velocity. So that velocity can be both positive or negative regarding to its direction. The total time taken during the motion must always be positive. Average velocity is the rate at which of displacement occurs. By the formula, you may write average velocity equals to displacement delta x over change of time delta t, or displacement delta x equals to final position xf minus initial position xi divided by final time tf minus initial time ti. Average speed is not same as average velocity, but these two quantities has the same SI unit, which is in meter per second. Average velocity is also a vector quantity. It tells us how far something is moving with the direction of the object. If an object is moving in the positive direction, the magnitude of average velocity is greater than 0. This is because of the final position must be greater than initial position. Otherwise, if an object is moving in the negative direction, you may get the average velocity less than 0. This is because of the final position now must be shorter than initial position of the object. Velocity can be determined from position versus time graph. We plot position x on the y-axis and time t on the x-axis. The magnitude of average velocity equals to the slope of the graph. If an object is moving with a constant velocity, the graph shows a straight line. To calculate the slope of the graph or the average velocity from the graph, the student may use the formula as the change in vertical axis, delta y, divided by the change in horizontal axis, delta x. When the moving object changes its velocity, we may have a curved path graph. This motion is called as non-constant velocity. Therefore, a position versus time graph is not a straight line graph due to the changing of the velocity. The magnitude of average velocity is the slope of the graph. To having this, student needs to draw a straight line from initial point to final point, as shown as the blue line on this graph. The instantaneous velocity can be defined as the average velocity in the limit as the time interval becomes infinitesimally short. The magnitude of instantaneous velocity can be calculated from the slope of the graph displacement x versus time t. The slope of the blue line shows that the average velocity which approaches the slope of the green tangent line, which is the instantaneous velocity. Next is acceleration. Acceleration is symbolized by small a. By definition, it is changing of velocity, or we may say that acceleration is the rate of change of the velocity. To calculate the acceleration, we may have the formula acceleration a equals to change of velocity delta v divided by change of time delta t. Or you may write as acceleration a equals to final velocity vf minus initial velocity vi over final time tf minus initial time ti. The SI unit of acceleration is meter per second squared. You may also use the others unit such as centimeter per second squared and feet per second squared to indicate the acceleration. Acceleration is a vector quantity having both magnitude and direction. When the velocity and acceleration are in the same direction, then the speed of the object will increase with time. Therefore, the object is speeding up. Otherwise, when the object velocity and acceleration are in the opposite direction, the speed of object now decreases with time. We may say that the object is slowing down or decelerate in its motion. So students, please remember that a negative acceleration doesn't mean the object is slowing down. For example, if the acceleration and velocity are both in negative, the object is speeding up. Deceleration means a decrease in speed, not a negative acceleration. The instantaneous acceleration is the acceleration of a particle at a particular instant of time, not during a finite time interval. It is also defined as the limit of average acceleration as the time interval goes to zero. The closer the time interval delta t gets to zero, the closer ratio of delta v over delta t gets to a fixed number, which is the instantaneous acceleration. To find the average acceleration from the graph, we need to have a graph of velocity versus time. The slope of the line connecting the initial and final velocity represent the magnitude of average acceleration. Meanwhile, the instantaneous acceleration can be calculated from the slope of the tangent to the curve of the velocity versus time graph. The explanation for both average acceleration and instantaneous acceleration can be shown from the graph of velocity versus time. You can see here the slope of the green line is the instantaneous acceleration of the object. Meanwhile, the slope of the blue straight line between point P and Q is the average acceleration of the object. A motion diagram is a representation of a moving object at the following time intervals, with the velocity and acceleration vectors sketched at each position. Red arrows for velocity vectors and the violet arrow are for acceleration vectors. The time interval between the adjacent position of the car are assumed same. Diagram A shows the car moved the same distance in each time interval. Therefore, we can say that this car moved at the constant velocity and has zero acceleration. The diagram B shows the car is speeding up. This is because of the velocity of the car increases with time. This car has a constant acceleration in the direction of its velocity. And lastly, diagram C telling us about the car is slowing down or decelerate in its motion. This car has a constant acceleration in the direction opposite of its velocity. A particle moving along the straight line on the x-axis with constant acceleration can be studied on the three different graphs. The first graph is graph acceleration versus time. As you can see here, the slope is zero. This is due to the constant acceleration between the initial point to end point. When we calculate the area under the graph, we may get the velocity of the object. The second graph is graph velocity versus time. It has a straight line graph, meaning that the slope of the graph has a constant acceleration. When we calculate the area under the graph, we may get the displacement of the object. The third graph is graph position versus time. When we calculate the slope of the graph, we may get the velocity of the object. Before you start solving the problem in one-dimension motion, let's identify four kinematics equations involved. So students, please remember these four equations are used in the situation that has uniform or constant acceleration only. The first equation is V equals to V naught plus AT. The second equation is delta x equals to V bar t. The third equation is delta x equals to V naught t plus half AT squared. And the last number 4 is V squared equals to V naught squared plus 2a delta x. V stands for final velocity. V naught stands for initial velocity. A is for acceleration, T is for total time taken, delta x is for displacement, and V bar is for average velocity. To understand and apply these four equations, let's do the exercise from the textbook.
Okay, so do you have any problem or do you have any questions regarding the topics that I played just now? Do you have a questions? Maybe a quick questions before I can discuss it further.
Laju sangat.
So, dah tengok belum?
Ada.
Okay, apa? So let's recap whatever it is. Some of you have said about the laju. Okay, of course. Sebab nak buat video kan, tak boleh dah lambat-lambat. Kena buat laju lah. So kalau laju saya cuba play uh, no, I have a questions. Her slide is different than yours in terms of the side chapters. What do you mean by Faik Nazhan? What do you mean by side chapters?
Oh, maksud saya macam I was watching the video that you're showing while the other side of the screen I have your slides downloaded from the
Okay.
U-Future. So like her
Okay.
slides, like she said, like there's chapter 2.1 and then suddenly 2.4, 2.3, 2.2. Like compared to yours is like 2.1, 2.2, 2.3. So yeah.
Okay. Basically, what she's been referring to is yeah, I should refer it first on your book. 2.1 is displacement, 2.2 is velocity, 2.3 is acceleration, 2.4 motion diagram, 2.5 one more dimensional motion with constant acceleration, and 2.6 free falling objects. Okay. So to answer your questions, can you show me my slide that you downloaded from your future? Right?
Sure.
Present now.
Can you see?
Not yet. Okay. Okay.
Okay.
Go a bit up. My first, go to my first slide. Second one. Okay, this one. This one, yeah, you downloaded it from my future.
Yes.
Okay, this is actually the same thing. But in terms of delivering is quite different because she is using another I'm using the same concept, but this is taken from the other books, the other textbook. Okay, so basically the
I see.
questions, and of course the terms used from my slides and compared to her slides is quite different, but the content is still the same. Okay, so we'll see afterwards, right?
Okay, understand.
Okay, fine, thank you.
Okay, thank you, sir.
Right, sure. Okay, so let's look and what should you highlight here. I'm going to show you the PowerPoint slides of her. Okay, so this basically her slides about the motion in one dimension. Just want to highlight a few things like this one, like I just said just now. So she's Madam Ain is actually discussing about displacement, velocity, and acceleration for 2.1. You will learn for this week. You will learn some things that are related to 2.1, 2.2, 2.3, and also 2.4. And of course, you cannot see the learning outcomes over here. Basically, that is there. In terms of displacement, I think there is not quite a difference between my slides and her slides because it's defined in terms of frame of reference. Okay, meaning that you must know what is the difference between displacement and distance. Okay, the distance basically jarak, but the displacement in Malay we call that as sesaran ataupun beza antara dua point, dua titik. Okay, so that's why when we deal with something related to displacement, of course, displacement is a vector, while distance is a scalar quantity. Okay, So that's why the different definitions of the displacement is the change in position. When you mention a change in position, that means the final point minus the initial point, regardless of how much is the total uh, distance between the point. Okay, it's just that we need to minus the final position. Okay, you minus to the initial positions. Okay, and of course SI unit for displacement is meter, and this is vector quantity. Okay, so this is this examples of the displacement taken from here. So I want to show you my slides. So this is basically my slides, the same things, just in terms of delivering, just different in terms of delivering. So you can see here, okay, I want to show you the displacement. Of course, when we have a displacement, then we can have an average speed. So what does it mean by speed? Sometimes people tend to have a difficulty in differentiate between speed and also velocity. Of course, speed and velocity actually have the same concept. Okay, the concept is just length over time. So that is just speed and velocity. But there's a narrow margin between speed and velocity because speed is actually scalar. When we talk about scalar, is always depends on the distance. Okay, speed is depending on the distance, while is a vector quantity. When velocity is vector quantity, then we need to make sure that on the length punya part tu, we want to put it as displacement, not distance. Okay, so when we talk about average, the word average means purata. Okay, the word average means we have to measure, we have to count every point, we have to count every distance value, and we divide with time. And of course, the SI unit is still meter per seconds for the speeds. Okay, look at these examples. Okay. Can everyone see the examples?
Boleh, sir.
Okay, good.
Yes.
A turtle and a rabbit engage in a foot race over a distance of 4 kilometers. The rabbit runs 0.5 kilometers and then stops for 90 minutes nap. Upon awakening, he remembers the race and runs twice as fast, finishing the course in a total time of 1.75 hours. The rabbit wins the race. Number one is calculate the average speed of the rabbit. The average speed, when you mention the average speed, meaning that you need to put everything that related to distance. Okay, put the total distance over the total time, or it's as saying in the slide, is the total path length, meaning that the total distance which mean in the race is 4 kilometers, and of course the rabbit finish it in 1.75 hours. And if you notice in the questions, okay, there is some confusion in terms of what is actually the SI unit. Okay, what is actually does this question follows the exact SI unit that we learned before? Okay, so in this case, in this problem, the SI unit used is we should know that the SI unit is always for speed is actually meter per second, but in this case, okay, in this case alone, when they are talking about kilometers, how many kilometers, maybe how many hours, so we should focus on what they've been what they tell inside the questions. Okay, so if the question asks you about kilometers and hours, of course we need to do it in kilometer hour, but you can always convert from kilometer hour to meter per seconds. Never mind. No, this is okay to do the questions in the kilometer an hour, and of course you can always change to the meter per second. Okay, so no problem. Okay, no issues in terms of the SI unit, right? But right now you want to learn about how can you say how can you define speed and velocity, how to differentiate between speed and velocity in terms of the questions. Okay, so on the first part is the rabbit runs 0.5 kilometers and then stop for 90 minutes nap. You can see inside these questions, they actually try to make us confused in terms of the unit used. Okay, they are also mentioned about 90 minutes nap. Okay, so the 90 minutes nap is actually want to just give you a bit of confusions in terms of what should I use the SI unit? What should I use about the unit? Maybe minute, maybe hour, maybe seconds. Okay, so that's why they are trying to make sure you confuse. But I can guarantee at your level, okay, at your level in Asasi, all right, so you will not see this kind of problems because we don't want to actually test you in terms of we don't want to make you confused. Okay, in fact we try to make sure that the question is always very clear for you to understand. Okay, so don't don't worry about that. Okay, so the calculate the average speed, so you can see the path length is 4 kilometers divide with the total time which the rabbit with the race, so it's about 2.29 kilometers per hour. Okay, and of course you can always change kilometer per hour to meter per second. We already discussed it during our lessons here last week. Okay, so of course in the part B, what was his average speed before he stopped for a nap? Okay, before he stopped for a nap. Okay, so what is it? What was his average speed before he stopped for a nap? So at 0.5. Okay, at 0.5 kilometers. Okay, so um, inside here, so you can see 0.5 90 minutes nap when we try to convert it to hours. So it is actually how many 90 divided by 60 times. Okay, it's about 1.5 hours. Am I right? Cuma boleh ikut ke? 1.5 jam. Betul eh? Boleh ke?
Boleh, boleh.
Boleh.
Okay, boleh ikut eh. 1.5 90 minit bersamaan dengan 1.5 jam, 1.5 hours. Okay, so the total time taken for the rabbit to win the race is 1.75. So right now 1.75 minus 1.5, so you can get 0.25 hours. So that will be the only time taken for the rabbit before he stops for a nap. Okay, so that's why we are saying here there are two different time taken. Okay, you can see T1 plus T2 equivalent to 0.25. See, 0.25 is the difference between the nap and also the time taken for overall winning. Okay, overall winning 1.75, and bila dia nap dia ambil lagi masa 1.5. Jadi dia ambil masa hanya berapa lama? 0.25 sahaja, 0.25 hour sahaja untuk dia berlari. Okay, so that's why kita gunakan formula. Kalau you see, tengok betul-betul ada satu formula daripada asalnya T1 plus T2 equals to 0.25 hours, tetapi bila dia untuk dia selesaikan benda ni, since kita tidak ada velocity 1 and also velocity 2, okay, kita tak ada kan. Yang tu yang kita nak cari. Kita hanya ada distance sahaja, which is 1, 0.5. Jarak dia 4 1, 0.5. Satu lagi 3 kilometer. So of course Sebabkan daripada ayat tu dia bagi tahu the race lepas dia terjaga, rabbit itu berlari 2 kali lebih laju daripada yang asal. 2 kali lebih laju. So that's why disebabkan itu kita boleh, sebenarnya dia ada 2 speed tau. Speed pertama sebelum dia sampai masa dia daripada 0 km kepada 0.5. Okay, dan speed kedua ialah pada 0.5 sehingga 4 km. So itulah speed yang kedua. Okay, tetapi speed pertama dan speed kedua sebenarnya digabungkan oleh disebabkan speed pertama ialah 2 kali speed kedua. Okay, sorry, speed kedua ialah 2 kali speed pertama. Itu baru tepat. He runs twice as fast. Boleh faham kalau awak tengok dekat situ dia buat V1 asal dia D1 over V1 plus dengan D2 over V2 is actually taken from daripada mana ni? Daripada average speed yang biasa. Okay, maksud dia V sama dengan D per T. Distance over time. So dia tukar kan. Jadi kita nak cari time dia. Okay, sebab dalam time itu ada velocity. Okay. Time kita hanya ada yang biasa saja, cuma kita tahu ada 2 jenis timing dapat 0.25 lah. Right? So in the end, yang paling best sekali ialah pada part nombor 2 tu, which is V2 yang kita tak tahu tadi ialah bernilai 2 kali V1. And of course, when they do the algebraic equations like this, and the V1 will is equivalent to 9 km per hour. Okay, 9 km per hour. So itulah jarak dia yang dia lalu sebelum dia sampai kepada, sebelum dia tidur, sebelum dia nap. Selepas dia nap jadi berapa?
18.
Berapa?
18.
18. Yes, 18 km per hour. Runs twice as fast as before he nap for 90 minutes. Okay. So ini soalan-soalan ni kita ambil apa bila mention about motion ni, kita kena faham konsep speed, velocity and acceleration. Okay. Alright, kita cuba bagi tengok balik average velocity. Okay, what is average velocity? Apa beza dengan average speed? Average speed dia ambil total distance over total displacement. Over total time. Average velocity sama juga. Cuma dia lebih kepada point. Mana dia? Initial point, initial position, final position, XF, minus with initial position, divide with the final time over initial time. Meaning that you can do everywhere. Okay, dalam satu kawasan tu asalkan ada point akhir dengan point awal, that's it. That is only what we want. Okay, if an object move in a positive direction, then the V bar atau the average velocity will be positive, will be greater than 0. And if an object move in a negative direction, then negative V or negative acceleration, negative velocity will be less than 0. Okay, ada satu saya nak mention juga mengenai instantaneous acceleration. So what does it mean by instantaneous acceleration? Okay, instantaneous velocity. Ada dua, instantaneous velocity dengan instantaneous acceleration. So the instantaneous velocity V is the limit of the average velocity as the time interval delta t becomes infinitesimally small. Belit dia dah. Becomes infinitesimally small, meaning that it's going to be very, very small, but it cannot be 0. Okay, delta t cannot be 0 because when delta x divide with 0, what will happen? Okay, if the delta x divide with 0, then it will be undefined. Okay, you cannot. So meaning that the delta t should be very, very small, okay, approaching 0, but not the 0. Okay, close to 0. So that's why we can get dx over dt. And normally, if you find the questions, okay, normally in the x versus t or maybe v versus t graph, so okay, you can see that the instantaneous velocity is where you measure or you must be able to understand the concepts of a differentiation, a bit differentiation. Kenapa? Kenapa differentiation? Okay, cuba tengok graf yang di bawah ni. Graf yang di bawah ini ialah graf position against time. Okay, so biasanya kalau kita nak check balik tadi, the average velocity dapat daripada mana? Dapat daripada gradient of the graph, slope of the graph ataupun kecerunan dia. Okay, tetapi kalau dalam figure yang saya tunjukkan sekarang ni, okay, macam mana kita nak cari kecerunan kalau graf itu berbentuk curve? How can we get the slope, okay, when there is a curve graph? So we need to define, we need to put, and we need to draw a tangent line. That's why, okay, tangent line yang warna hijau ni, kita lukis dekat satu point. Supaya when we have a time interval ataupun ada time yang kita nak tahu dekat mana berlakunya instantaneous velocity, dekat situlah kita cari. So biasanya untuk instantaneous velocity ni dia akan bagi satu contoh dia bagi satu function. Kan graph curve kan ada function kan. Kalau macam function macam ni mungkin dia ialah quadratic function. So y equals to 4x square plus 8. Katalah contoh 4x square plus 8. So bila dikata ataupun kita guna x pun boleh. X equivalent to 4t square plus 3. Contoh dia 4t square plus 3. Okay, x equivalent to 4t square plus 3. Okay, sebab dia position against time, x against t. Okay, so macam mana nak buat? So dia kena buat dx dt. Dx dt maksudnya kita
Differentiate.
differentiation apa differentiate tu apa Melayu dia? Perbezaan dia.
Ya.
Pembezaan.
Perbezaan kita buat perbezaan dx over dt, maksudnya kita dapat apa tadi? Kalau 4t square plus 3, so kita akan dapat 8t. 8t kan? 8t tu katakanlah dia nak pada time t equals to 3 second, so 8t, 8 tu t tu kita gantikan dengan 3. Nanti saya akan tunjukkan contoh-contoh lain lah. Right, so this is the second example. Okay, maybe you can have something from here. A train moves slowly along a straight portion of track according to the graph. Okay, kamu tengok dulu. Saya akan ni sebab azan. Stop sekejap. Okay, so let's continue. A train moves slowly along a straight portion of track according to the graph of position versus time. So dalam tadi ikut Madam tu cakap, there have three graph which is X versus T, V versus T and of course ada A versus T. Tapi yang biasanya kita akan buat ialah X versus T dan V versus T sahaja. And of course you need to know what is the meaning of the slope. You need to know what is the how significant is area under the graph, setiap graph tu. So that's why kita boleh belajar setiap satu. Okay, let's contoh dia, find the average velocity for the total trip. Okay, so average velocity. Velocity is time taken, total distance or total displacement over total time. So how many displacement? So from 0 until 10 meters. Okay, so divide with 0 until 12 seconds. So that's why 10 divided by 12. So you can see here, okay, the average velocity is positive 0.833 meter per second. Okay, on part B, the average velocity during the first 4 seconds of motion. The first 4 seconds of motion meaning that you ambil dekat graph, tengok at 4 seconds now, okay, so you project it to the graph and of course tengok dia punya gradient dia dekat situ. So maksud dia kalau ikutkan gradient dia dekat situ, 4 bahagi dengan 4 dapatlah 1 meter per second. Untuk soalan B ya. Okay, untuk soalan C, the average velocity during the next 4 seconds. So nampak antara A dengan B next 4 seconds tidak mempunyai a slope. Masalahnya maksudnya kalau kita kira gradient dia 4 tolak 4 mestilah kosong kan, bahagi dengan 8 tolak 4. Bahagi dengan 4. So kosong bahagi dengan 4 masih lagi kosong. And D, okay, part yang paling penting, the instantaneous velocity at time t equals to 0. So biasanya soalan instantaneous velocity ni always mention about at specific time. Okay, at time t equals to berapa, sebab dia nak tempat yang tepat, dekat mana berlakunya instantaneous berikut. Okay, contoh dia yang pertama, D dia kata nak T equals to 2. Dekat mana? So, T equals to 2 seconds. Now, you project it to the graph. Maksudnya panjangkan kepada graph. Naik straight ke atas. Lepas tu, oh okay, rupanya dia duduk di antara gradient yang antara O dengan A. So, that's why jawapan dia sama dengan 1. Okay, untuk soalan D. And untuk soalan E, the instantaneous velocity at time t equals to 9 second. Where is 9 second? 9 second duduk antara 8 dengan 10. So you try to project it to the graph. Maksud dia project daripada bawah sampai ke line yang ada orange tu. And then tengok, oh punya dia duduk dekat graph yang berbentuk curve, a very curvy graph. So how to handle a curvy graph? Therefore, we should draw a tangent line. Yang kali hijau tu ialah tangent kepada point tadi. Tangent kepada point 9 seconds. So that's why kalau tengok dekat situ, calculation dia ialah 4.5. Siapa 4.5? Di sini. Okay, 4.5 ialah di tengah-tengah ni. 4.5 minus dengan kosong bahagi dengan 9 tolak dengan dekat sini lebih kurang 3. So sebab tu jawapan dia 4.5 tolak kosong, 9 tolak 3 dapat 0.75 meter per second. So that's why bila diberi graph senang, tak ada masalah. Kalau diberi graph untuk jawab soalan instantaneous. Okay, kalau tidak diberi graph, please look at the function. Okay, tengok kepada function. Function ada, okay, tak ada masalah. Boleh ke? Okay. Ada soalan? Boleh terima lagi? Okay, so tengok satu soalan lain. A jet engine move along an experimental track which we call the x-axis as shown in figure. So ini ya. We will treat the engine as if it were a particle if its position as function of time is given by the equation. Nampak ada equation. X equivalent to AT square plus B, where A is 2.1 meter per second square and B is 2.8 meters, and this equation is plotted in figure B. Jadi dia buat, dia dapat data tu, dia plotkan pada figure B. Okay. Determine the displacement of the engine during the time interval from t equals to 3 seconds to t to 5 seconds. Mana 3 to 5? Di sinilah 3 to 5. So kita project di atas ni, therefore we need to do a slope over here and we need to calculate the slope. Okay. So from 3 to 3 to 5 seconds. So jawapan dia berapa tu? Soalan ni lebih kurang 33.6. Okay. Tapi in the end sebenarnya kalau tengok for solution for part A dia buat macam mana? So x is equivalent to at square plus b, itu dia bagi function, and then of course dia replacekan t dengan time yang ada, which is 1 untuk 3 second, 1 untuk 5 second. So maksud dia x2 dengan x1. So ini lebih tepat, maksudnya bila diberi graph dan juga diberi function, better to use function. Sebab function kita ada function t, so we can calculate. So therefore 55.3 minus with 21.7, therefore kita dapat 33.6 meters for the displacement. And how about B? Determine the average velocity during this time interval. Average velocity, again, the total displacement over total time. So what is the total displacement? Berapa? So tadi kita dah mention about displacement yang kita dah calculate tadi. So we can easily use 33.6 divided with 2 seconds. So definitely you can get average velocity. Sebab average dalam soalan ni, average velocity merujuk kepada the time interval. Time interval bila? 3 to 5 seconds sahaja, bukan keseluruhan 3. Okay? Bukan keseluruhan 3. And of course, the last part will be determine the magnitude of the instantaneous velocity at time t equals to 5 seconds. Tengok perkataan dia, instantaneous velocity. Function yang dibagi ialah x. Apa maksud x? Function position. Maksudnya kita kena buat differentiation. Kena differentiate dulu apa yang berlaku, dia buat macam ni. So this is the function x equals to at square plus b. And of course dia dx over dt untuk dapatkan v. Okay, dx over dt untuk dapatkan v. And then dia dapat 2 at. And then finally apa yang dia buat? So dia gantikan t tu dengan 5 seconds. Therefore, you'll get 21 meter per second. Okay, so that's how you encounter the problem using this part of it. So ini antara benda-benda yang mungkin awak sebenarnya tak ada masalah. You don't have problems because you already learn these things. But in here, we only discuss it further in terms of how to maybe in your school days, okay, you only be given with the value, information. Dah bagi ni, okay, cari sendiri. Right now, kita ajar you macam mana nak tengok kepada graph. Okay, maksudnya daripada graph tu, you can tell banyak maklumat yang berada dalam graph. Ada soalan?
No, sir.
No,
Ada
sir.
Okay, kita tengok satu soalan lain. Mungkin example this one untuk acceleration. A baseball player move in a straight line path in order to catch a fly ball hit to the outfield. His velocity as a function of time. Velocity as a function of time maksudnya v versus t. Find his instantaneous acceleration at point A, point B dan point C. Nampak? Point A, point B dan point C. Okay, untuk bahagian belah kiri, bahagian belah kiri. Point A berapa? So kalau tengok point A ialah duduk antara ni. Duduk antara 0 kepada hujung ni. So kita nampak berapa dia punya V? 4. 0 sampai 4. 4 tolak 0, 2 tolak 0. Therefore dapat 2 meter per second square. Perlu tak kita buat macam limit-limit ke? Perlu tak kita buat macam differentiation? Tak perlu. Sebab dia tak bagi function, dia terus bagi dia terus bagi pada line graph. Okay, so we don't need to do function. We don't need to differentiate the function. Okay, let's look at point B. Where is point B? Di tengah-tengah ni. So nampak tak dekat situ, point B tu duduk di dalam keadaan flat. Bila duduk pada keadaan flat, definitely it will be berapa tu? 0 lah, sebab 4 minus 4, okay, over 3 minus 2. So definitely 0. And how about part C di bawah ni? So kita akan dapat, of course, bila ada dalam D, kita dipanggil deceleration. Madam tu cakap deceleration tu bukan ni, maksudnya is actually a slowing down. Okay, the slowing down. So that will equal to negative 2 meter per second square. Okay. Right. So nanti cuba tengok balik nota-nota ni sebelum kita sambung ke dalam next video, which is yang melibatkan 2.4, free falling objects. Okay. So ada apa-apa nak tanya ke sebelum kita habiskan?
No, sir.
Okay, very good. Okay, so anything, if you do have a problem, you do have a questions, then please masukkan kuat soalan tu dekat saya punya future. Saya dah tunjukkan pada kamu. Okay, masukkan dekat future tu dalam saya punya forum, letak dekat situ. Okay, I will answer it as soon as I ada time. I akan terus jawab kat situ lah. Okay. Alright, so thank you very much everyone. Thank you for your attention. So I'll see you. Ada kawan tanya, Syahdatul Nur Akila, esok ada ke lab session for physics? Lab session belum lagi. Lab session pada minggu keempat baru mula briefing. Okay, minggu kedua, ketiga masih lagi tak ada apa-apa. Okay, ada soalan lain? Good. Thank you very
Tak
much.
ada, sir.
Okay. So